Good evening, everyone. Am I audible? Hello?
Yes, ma'am, audible.
Okay. Thank you for the confirmation. So, welcome to the third week of the course, Water and Wastewater Treatment. So, my name is Mansi Tripathi. So, overall, there are three TAs for this course. All three of us have been allotted different times. So, you can join any of the sessions. Okay, you can join all two or any one of the session that will be beneficial for you so that we can understand and we can solve some few basic problems that will help you to solve the assignments as well as crack the examination. So this is the sole purpose of the course. So I am the TA which has like I'll be taking lectures only on Tuesdays. Other two TAs will take on Mondays. So this is just for the information that I have to repeat every week so that you can understand. Okay, so what do we do in this course is that we we solve few basic questions. Okay, I'll share my screen. Then there will be some questions. Please try to solve them on your own. We can match the answers. So that is the way you will learn better. So I'll share my screen now. So this is a third week of the course. Here mostly we have discussed about some of the water quality parameters, especially the pathogens. Then we have moved towards the quantification. How do we quantify them? There are many methods, especially the headworks that we do to quantify the water. We have talked about partial flume as well. After that, we have moved towards the treatment plant. So basically, there are many steps in the treatment plant, starting with the preliminary treatment that can be used to remove very big particles as well as inorganic particles. Then moving towards primary treatment, which involves some organic and mostly inorganic particle removal. Then we are moving towards the secondary treatment, where we use biological means to treat the water. So here we remove all the organic contaminants. After that, the next process will be disinfection. But there are certain set of reuse applications where more treatment is required. So this more treatment is given in tertiary treatment. So that depends upon the reuse application. We do not do tertiary treatment in every type of water, but we do when it has certain reuse application as well as if the discharge uh, say the discharge requirement are not met. Okay, then I'll show some questions. Please try to answer in the chat box. The first question is numerical. So, a municipal corporation is required to treat 900 meter cube per day of water. It was found that overflow rate is 16 meter per day and depth is 3.5 meters. So, that diameter we need to find out. Okay, we are giving these things so that when these type of question will come in examination, you have to be very sure while writing the decimal places. Otherwise, the system will read it incorrect. So from now onwards, whatever the questions we will solve here will be kind of similar to that you are gonna get in your assignments as well as the examinations. So here we are supposed to design a circular settling tank for the removal of discrete suspended particles. So when in this question, this is a numerical question, but let's try to find out as much information as possible. Here we are saying a circular sedimentation settling tank for the removal of discrete suspended particles. So what type of tank it can be, primary or secondary? You can answer in the chat box. You can solve the questions also and just answer this one very interesting question in the chat box. We are removing discrete suspended particles. So what type of sedimentation tank it is, primary or secondary? Means first degree or second degree?
Primary.
Okay, very good, very good. Because we are removing discrete suspended particles, so we are considering every particle on its own. They are not interacting. When we say discrete, they are not interacting. And these are quite heavy. So they may settle very nicely. So that's what we do. We consider that we do in primary sedimentation tank. This is ideal situation. This is not possible every time because there will be some particles that are forming flocks. But this is what we consider ideally. Now please try to solve the numerical question. We have Q, we have overflow rate, we have depth. Let's mark it with H. What we need to find is D. Please try to solve this question. I'll give you a minute. Okay, we'll see the answers now. Very small answer. Q is given, SOR is given. So what will be the surface area? So this is your tank. It's a circular sedimentation tank. So Q is coming. And what is SOR? SOR will be this velocity. How the particles are moving down, mean settling velocity. So when Q is divided by SOR, what we will get? We will get the top surface area. Okay, so this is the surface area. And when we will put it in the formula, we will get the value of diameter. This diameter we will get. You must have already studied in discrete settling. This H is not required. Height is not required. Okay, let's move towards next question. This is a type of match the following question. So here we have given the function or the principle of the particular unit and the types of treatment unit. So please try to match this question. Type of treatment unit with their principle. This is very important question.
A.
Okay. Yes, your answer is very correct. When we talk about pre-treatment, we talk about grit removal because there are three methods, three treatment schemes. First is preliminary, then primary, then secondary. In the preliminary treatment, what happens? We have screens as well as grit chamber. So grit removal is performed there. So it is kind of pre-treatment. Second is suspended growth biological treatment and attached growth biological system, biological treatment. So what is suspended? Suspended means in a tank, all the biomass will be present throughout the system. Okay, any organic matter will come, organic matters are coming. We will mix this system properly so that all the organic matter comes in contact with the bacteria or the biomass and the clearer effluent will come out. But what happens in suspended system? In a tank, what happens in this one is suspended. What happens in attached? In a tank, there will be some media, means sand or pebbles or anything, some media will be there. Around them, the bacteria will attach themselves. There will be a formation of biofilm. So this is the example. This can one example can be trickling filter. Here in trickling filter, it works like a filter. There will be many particles, pebbles, stone, everything. So it will form a layer. It will form a thick layer, and water will pass from one side and it comes from the other side. Very clear water will come from the other side. In suspended, mixing is required. In attached, mixing is not required. So this is how suspended and attached growth system are differentiated. So attached growth trickling filter, suspended aerated lagoons or ASP activated sludge process, and fourth is disinfection. So UV is one such disinfection technique. Why do we do disinfection? To remove the pathogenic organisms from the water body. Let's move towards next question. This is also a match the following question. So here we have to find out the discharge. We are discharging the water into surface water. So we have to find out the discharge standards according to CPHEEO. Please try to answer this question. Okay, we'll see the solution now. The solution is C. POD 100, suspended solids 100, dissolved phosphorus will be 5, and total nitrogen, just a second. Oh, BOD is 30. Okay, yes. I, I have written correctly but spoke wrong. BOD 30, simple, suspended solids 100, dissolved phosphorus is 5, dissolved nitrogen means total nitrogen is 30. Now, yes, we are monitoring BOD and suspended solids. If the BOD is very high, the oxygen will reduce. If the suspended solid is very high, what will happen? The water will become very turbid. But why do we monitor this phosphorus and nitrogen? Is there anyone who can tell? You can answer in the chat box also. Why do we monitor phosphorus and nitrogen?
To avoid algae formation, ma'am.
Yes, very correct. So what happens when the dissolved phosphorus as well as nitrogen level is very high? I'll give you the values. in most of the researches, what has been observed, that nitrogen, if it is greater than even zero point 0.1 milligram per liter, and phosphorus, if it is greater than 0.02 milligrams per liter, eutrophication is happening. So, okay, what is eutrophication? Eutrophication means increased productivity of the lake. What does this productivity means? When the lakes are more productive, more plants will be there. And what plants we are talking about? Algae. We are not talking about big macrophytes. We are talking about microphytes. So algae is one of the example of microphytes. What will happen if the dissolved phosphorus and nitrogen are more? There will be more algae formation. So they will cover the whole lake or any water body. A mat formation will be there. When there is too much algae, sunlight won't be able to penetrate. When sunlight is not penetrating, the plants which are present inside won't be able to perform photosynthesis. So it will decrease the oxygen level inside the water body. When the oxygen level are below what value? 4 ppm. Okay, when the oxygen level is below 4 ppm, all the uh, fauna and flora present inside the water body, for example fishes, zooplanktons and other organisms, they won't be able to breathe, so they will be finished off from this water body. So this is what happens when algae mat is there. Sunlight won't be able to penetrate and these problems will happen because there is no photosynthesis to produce the oxygen, and these algae are also producing oxygen but they are consuming it too. So here what will happen, only algae will produce oxygen, that too in daytime. Okay, and it won't be sufficient to sustain all the fauna inside the water body. So, and there are more consumers than producers inside the water body because plants are unable to contribute due to the formation of this thick mat. And when these algae will die, they will also consume oxygen. It will be a form of BOD. They will also consume oxygen. So, because of these effects, eutrophication can go on for many days. Let's move towards next question. This was just for some extra information. It will be better if you can understand it in a dynamic way. So this is question number 4. Among the following, which is or are pre-treatment units? So it can have multiple answers also. So please try to answer this question. We are talking about pre-treatment units. We have discussed something like that in the previous questions. So please answer this question.
Is it A and B, ma'am?
Okay, we'll see. Yes, answer is very correct. So why do we use bar screen? Because in wastewater there may be plastic, papers and very big particles. So what do? We use bar screen so that these plastic can be strained out. Then we will take these plastic, we will move the water further to the grid chamber, and about all those plastics and all we will put them in municipal landfills. Okay. Then the water moves towards grid chamber. Here what happens? Big inorganic particles like sand and all, it will settle down because the detention time is very less. So only inorganic particles will settle down. So that is what do we try to do. After that, what happens in flow equalization and proportioning tank? Because in the further downstream, we want a constant supply of water. We don't want very high fluctuations. So Proportioning tank and flow equalization systems are there so that a constant supply can be ensured. So these comes under pre-treatment units. Okay. If in case of any doubt, you can ask in between. Okay. So we'll move towards next question. Select the correct assumption related to ideal sedimentation tank. Okay, we are talking about ideal sedimentation tank. Please try to answer this question. Okay, we'll see the solution. So first is type 1 settling is assumed. So here we are talking about ideal sedimentation tank. So we are talking about the primary sedimentation tank. So here we assume type 1 settling means discrete particles are settling. So particle entering outlet zone. So B option was particles entering the sludge zone aren't captured. So this is wrong. Whatever enters the sludge zone, it is taken out. So it is captured. C is particles entering outlet zone are removed with water. So very true. All the particles that are entering the outlet zone that are not captured in the sludge zone are removed with water. D is non-uniform distribution of particles throughout the depth of inlet zone. So this is very wrong. We try to distribute it very uniformly. That's why sometimes in sedimentation tanks we use baffle walls so that all the particles is distributed very uniformly inside at the inlet zone. Even distribution of flow entering and leaving the settling zone. So this is also correct. Let's move towards the next question. For a grid chamber, it is recommended if the recommended flow velocity for a grid chamber, if the recommended flow velocity is 0.32 meter per second and the detention period is 1 minute, then what is the length of the tank? This is very simple question. It won't take more than 30 seconds to be solved. Please try to answer this question. Up to 2 decimal places fine. Take care of the units while solving. Okay, let's see the answer. So flow velocity is given in meter per second, 0.32. A detention time is 1 minute, that is 60 seconds. So what will be the length? Flow velocity into detention time. So here is what we got. Please check the calculation. I hope you understood what we are trying to do. So how this grid chamber works? Grid chamber is in the form of long stream from where flow is coming with the velocity 0.32 meter per second. Okay, so detention time is given. We need to find out the length. When the time is given, velocity is given, we can easily find out the length. And with this information, we can find out the area also. And if we have detention time, we have Q, we can find out the volume, area, depth, everything we can find out. It's very easy to solve. There can be many more questions in this single question. Let's move towards next question. For a given discharge, the efficiency of sedimentation tank can be increased by. So these are four options by which we can increase the efficiency of sedimentation tank. Please try to solve this question. You're not audible.
Increasing the surface area of the tank?
Yes. Anything else? Okay, we'll see the solution. So yes, very correct. Increasing the surface area of the tank. And how do we exactly increase the surface area? Any idea?
Ma'am, pardon ma'am?
Like how do we increase the surface area? Yes, one
Because
option.
we,
Like, I'm asking
because
how do we increase? Hmm.
how do we increase?
Yes. And yes, one option is correct that we can use increase the length. But what if I'm just fixing this length? I don't have enough space, so my length should be fixed. I'm not going to increase the length. This is my sedimentation tank. I don't want to increase the length. So what else I can do to increase the surface area? Correct. Very good. We can use baffles, and what else we can do? So we use baffles to distribute the flow. It is not used to increase the surface area. Think what else we can do. This is the tank. I have only this much of space. How can I increase the surface area? What else I can do? Let's say I have kept baffle walls here to distribute the flow. But what else I can do to increase the surface area? You're not audible. Uh, you're not audible. You can type in the chat box. He's not audible for me only or for anyone else? Or there is some problem on
For
my.
everyone, ma'am.
Okay, you please write in the
For
chat box.
everyone.
Okay, thank you. You can answer in the chat box. So think of more ways by how we can increase the surface area. It's very simple thing. Don't think it in terms of environmental engineering or anything like that. Just think you want more surface. You want more surface in this one surface.
Are you providing circular tank, ma'am?
Circular tank is there. I am not going to change the circular tank. Circular tank or whatever tank I have, it is there fixed. I just want to increase the surface area. How will I do that? Think more. It's very simple. Ever heard of what do we call tube settlers? Okay, I'll tell. One option is tube settlers, or what we can do, we have to increase the surface area, right? So along this depth, we can put some more surfaces like this. So first water will come on this surface, some particles will be removed. Then it will come on this surface, some more particles will be removed. Then here, then here, then it will go towards the sludge zone. So this is the way we can increase the surface area. So surface area will be this plus this plus this plus this plus this. Understood? This is how we increase the surface area. Any doubt? Hmm? So in this case, the length is fixed, space occupied is fixed, everything is fixed. Just I have utilized the depth. I have kept many surfaces on that so that the whole tank can be effectively utilized by increasing the surface area. Okay, so in only that amount of time, more particles will be removed in the sedimentation tank because it has got more surface now. Moving towards next question. Question number 8 is select the correct statement regarding aerated grit removal. Earlier what we used to do, we just used to provide some detention time of 1 minute or so in the grit chamber and the inorganic particle used to be removed. Now we have used aerated grit chamber. So correct statement regarding aerated grit chamber. Please answer this question. It can have more than one answers. Okay, we'll see the solution now. So option B is aerated grit chambers are versatile which allow for chemical addition. So here what happens, sometimes the grit particles are not easy to remove. They will remain inside and they will cause some problems. So we try to add some chemicals so that these particles can settle down easily. Also for cleaning the grit chamber, sometimes we need some chemicals. So in aerated grit chamber, we can easily introduce these chemicals, and due to aeration, these chemicals can be mixed very properly and all the settled grits can be easily removed. So cleaning is very easy. C option is it has consistent removal efficiency over a wide flow range. So yes, aerated, because we are aerating it, we are mixing it properly, aerating it, so the efficiency will eventually increase. And option D, minimum hydraulic retention time is 8 to 10 minutes. That is not possible. We give very less time. Why? Because if more time is given, then the organic particles will start settling. When the organic particle will start settling, bacteria will start growing and there will be so much nuisance. Then we have to clean more and more and more. And there will be smell and all also. That's why we try to reduce the detention time to 1 minute so that only our inorganic particle settles. We are not allowing any organic particle to settle. That is the one reason we are using aerated grid chamber. Okay, let's move towards next question. The design goal of grid chamber is to provide sufficient detention time. I have already answered this question. Plus, but you try to solve in terms of maintaining constant velocity to scour organics. Okay, we are not allowing any organic particle to settle. We want to allow only inorganic particle to settle. So what will be the answer, true or false? Okay, we'll see the answer. Answer is true, because we are providing sufficient detention time for the grit. Grit means inorganic particles, and constant velocity are maintaining to scour organics. Scour means to remove organics. When the velocity is high, then the all organic particles that have settled, inorganic will settle because these are heavy. But the organic particles with the flow velocity, they can be scoured. So they can be removed. Scouring means removing. So that is why option A is correct. So this is how we try to design the grid chamber. There should be some minimum velocity that can remove the organic particles but allow inorganic particles to settle. Understood? Let's move towards next question. Question number 10 is, select the correct statement regarding type 2 settling. Now, till now we have been talking about type 1 settling, means discrete particle settling. Now we are talking about type 2 settling, that is flocculent particle settling. So what can be the uh, statements which are correct regarding type 2 settling? It can have many answers. So please try to answer this question. Type 2 settling is also called flocculent settling, flocculent particle settling, or flocculent settling. Okay, more answers?
A and C.
Okay, we'll see the answers now. So the answer is A and C. Question number A is, option A is, particle collide with each other and agglomerate, leading to flocculent settling. So that is why it is also called flocculent particle settling. Option B is, example of type 2 settling is in grid chamber. No, in grid chamber, what do we try to settle? It's inorganic particles, and inorganic particles are discrete. They do not interact. Ideally, they do not interact. In grid chambers, we want only organic particles to settle, inorganic particles to settle, not organic. So example of type 2 settling will be where sedimentation tank, type 2 sedimentation tank means secondary sedimentation tank that we use after biological treatment, second degree treatment. Okay. Option C is, due to velocity gradient within a liquid, cause particle with higher velocity to overtake those in adjacent stream path moving at lower speed. So yes, what is velocity gradient? Velocity gradient means in a layer, in a tank, for example a tank, different layers will have different velocity. So this is what we call velocity gradient. So for example, this is height h, this will have velocity v1, this layer will have v2, and this will have v3. So this is what happens in velocity gradient. So due to velocity gradient, particles having, just if for example v1's velocity is greater than v2, So the particles having v1 velocity will move faster than the particle having v2 velocity. So that is what it is written. So this is very simple thing to understand, that the particle having more speed will overtake the particle having lesser speed. Okay. Option D is combination of smaller particles to make larger particles leads to slower settling and creates a sweeping effect. So sweeping effect is not there in type 2 settling. Sweeping effect is there in type 4 settling. What happens in sweeping effect? There will be many particles that will join together. So if there is any particle which has not joined, when these particle will settle, it will take when these particle will settle, it will take these small particle and settle down. So this is called sweeping effect. This particle is not part of their bridge, but because these are so heavy, so they are over this particle. So while settling, it will also help the standalone particle to settle. Okay, so this is how sweeping effect works. So this doesn't happen in type 2 settling. Sweeping effect happens only when there are many particles. So this happens mostly in sludge, not in water. Sweeping effects happens in sludge. Okay, so let's move towards last question. Last question is quite big. It is a big numerical. So we can solve them in parts. So please try to solve that question, because next question I think it will definitely come in examination. So the question is, find the terminal velocity of the spherical particle. Please note down, the particle is spherical, diameter is 0.5 mm, specific gravity is 2.65, and it is settling through water. The settling velocity, when it is settling through water, then we can say it is either type 1 settling or type 2 settling. So we need to find out the settling velocity. So in the first instance, it will look okay. We can just use the equation and solve the question, but that is not how it works. So please try to solve this question. We have been given G, mu, and specific gravity of water and density of water. So what we will do first? We will assume that the flow is laminar. When the flow is laminar, we use this equation, G by 18 . Okay, please try to solve this question. At least try. This question is in 2-3 parts. So this is the first part. Please answer me, give me the answer for the first part. And please be very well aware about the units. This is meter per second square, Newton per second per meter square at 20 degrees Celsius. This is kg per meter cube, but we want answer in centimeter per second. And the particle diameter is 0.5 mm. So be very careful, be very consistent with the units. Try to change all the units into a single unit, then start the question. Give me the answer for the first part. Please use calculators and please very sure about the units, because if there is one mistake of point, you won't get the proper answer. So the first hint is assume the flow as laminar and use the equation, laminar flow equation, to solve for velocity. Okay, we'll see the solution. So first of all, this question is in many steps, as you can see. So first of all, we will assume the flow as laminar. So we will use, here I have not mentioned this. I'm so sorry for that. So D is particle size. So we will solve the question like this. Okay, this is the same equation, just in different form. It is in form of G. I have written in form of mu. Written in form of rho, means density. So by solving to this equation, we got the velocity as 0.225 meter per second. So our next step, what it should be, in most of the mistake that what we will do is we will report this as answer, but this is incorrect, because we have to check for the Reynolds number of laminar flow. As we know, for laminar flow, Reynolds number should be less than 1. So we will put this in Reynolds flow equation, that is rho d Vs by mu. And what do we found? This is not less than 1. This is not less than 1. Okay. So it means the flow is not Reynolds, or the flow is not laminar. So we cannot use this laminar flow, we cannot use Stokes equation. From where we found that the flow is transitional. For transitional flow, this will be the equation number 4. Here we have everything. We have G, D, G, but we don't have CD. How we will find CD? By this transitional flow equation. CD is equal to 24 by RE plus 3 upon under root RE plus 0.34. Why I was asking you to be careful with the units? Because of this RE under root. Because if the units are not proper, you will not get the proper result of under root. So after putting it Reynolds equation, this Reynolds equation in this equation, means we will put like this: 24 upon 112.5. Please give me the value of CD if you have calculated. 112.5 plus 0.34. Check if this is correct. So this is how we will calculate CD. After calculating the CD, we will kept it in Vs square equation and we will get the velocity. See, earlier what was the velocity? 0.225 meter per second. Now what we got? Almost half of that. So that is why we cannot report this. Be very careful what type of equation we are talking about. Means it is, if it is laminar or transitional, okay, or turbulent. We have to be very, very careful for that. Now we found out a transitional equation for the velocity, but we have to again check. Okay, what do we have to check? Reynolds number. We will check the Reynolds number. It came 56.65. When it came 56.65, what we have to do? This is transitional. It means we will use only transitional equation. You are getting my point, yeah? You're not lagging behind, right? You're understanding the question? Please answer. How do we have to follow all these steps? So first what we will do? First we will assume it as laminar. Then we will find out the velocity, the laminar. Just to check if the assumption was correct, we will put it in Reynolds number equation. Here when Reynolds number equation was calculated, it came 112.5, which is not less than 1. It means the flow is not laminar. Okay, I'll explain. So here we understood that the flow is not laminar. Okay, when the flow is, as you know, there are different types of flow: laminar, transition, and turbulent. Laminar flow, the Reynolds number should be less than 1, and for transition flow and for turbulence flow, Reynolds number should be greater than, we can say, depends upon the cases. When we talk about pipe flow, it should be around 4,000. So let's keep, it should be greater than 1,000 for now. In between, the flow is transition. For all three types of flow, we have different velocity equation. Okay, laminar, transition, turbulent. We have different velocity equation. So whenever we will get this type of question, first of all, we will assume it as laminar and we will put the equation in a Stokes equation. After putting in this equation, we will get some value of velocity. But we have to check if it is what type of flow we have assumed, if it is correct or not. Then we have checked the Reynolds number, rho d Vs. This Vs only we will keep and everything is same. It came 112.5, which is not less than 1. So this assumption went wrong. It is not laminar flow. So this is now transition flow. So for transition flow, as we know, there is different velocity. So that velocity is Vs square 4 by 3 Gd, G minus 1 Cd. And how do we calculate this Cd? So this is the equation: 24 upon Re plus 3 upon Re raised to power 0.5 means 3 upon under root Re plus 0.34. Okay, so this is step number 3 that we will do. After putting the same Reynolds number, transition Reynolds number here, we will get this value 0.836. We will use the same in this equation. So how we will use in step 4? Vs square is equal to 4 by 3. G is 9.81. What is D? 0.5 mm, right? So I am saying we have to take care of the units. So what we can do? We can put 0.5 into 10 ki power minus 3. It is now in meters. Then in bracket G minus 1. What was G? 2.65. 2.65 minus 1. Okay, divided by CD. What CD we got? 0.836. 0.836. So after solving this equation, we got this as velocity. After getting this as velocity, as we have checked earlier for Reynolds number, we will check again for Reynolds number. And we got Reynolds number as this. Okay. After checking for Reynolds number, we will again find out CD. After finding out CD, we will again find out Vs. Okay. So what was our earlier Vs? First Vs was 0.225. Second Vs was 0.1133. Third Vs was 0.0965, and the fourth Vs was 0.0 uh, uh, 0.0922. So when this question will be over? This question will be over only when, after doing multiple steps, we are getting kind of same Vs. So as I have told you, we want answer up to 2 decimal places. So after solving these questions multiple times, after solving the steps multiple times, means we will find out Vs again, then we will find out Re again, then Cd again, then Vs again, multiple times. Then we will stop only when last two digits are kind of similar. See, there is so much difference. Here also there is so much difference, but in these cases the difference is little less. 0.09 is same, here it is 0.22, and here it is 65. And the range which was accepted was of 2 decimal place, so you can answer 0.09, like that you can answer. And this is in meter per second. You have to convert it into centimeter per second, then only you will get the solution. So this question will be quite big. If you get this kind of question in the examination, you finish first all other questions, then keep on solving this answer until you get two similar answer in the last two steps. Okay, so this is how it will be solved. You understood, or there is some other doubt? Okay, very good. In Actually, in such type of question na, you will never get a correct velocity value. You will never get the correct velocity value. In such question, what happens? You keep on solving it until the answer is converging. So here you won't get a proper analytical solution. You can just get a convergent value which can represent the correct scenario. Okay, that's why in such questions always range is given. If you will do more trial after the 6th, 7th, 8th, 9th trial, you will get kind of similar answer, then only that answer can be considered correct. So the steps are never fixed. You can try more steps, but in some questions steps will be given, like it will be given you can do 3 trials. Whatever answer comes after 3 trials, you can answer and you can report the answer even if it is not converging. So what can be those 3 trials? First, laminar flow trial is not counted. These 3 transition flow trials will be counted. Okay, this is how it works. So that's all for today from my side. Please practice this question again. Okay, this question number 11, you practice again, and and in case of any doubt, you can ask me next week. But please practice this question again. How to do step 6. This is same thing only. Whatever we have done from step 1 to 3, same thing only. Step 6 also it is the same. You have to repeat the steps 2, 3, 4. You have to find again Re, then Cd value, then again you have to find Vs. So here it is just written, this portion it is written that these two steps, step 5 Vs and step 5 and 6 Vs are kind of similar. That's why it is written like this. You can do as many trials as you want until the answer converges, or if any question it is given, okay, you have to do these many trials, 4 trials, 5 trials, like that. So it won't be more than 3 trials. So after a laminar flow you have to do 3 trials, answer will come if you are following the process correctly. And please take care of the units. In such questions, units are very important. Most of the last time what has happened, students were giving answer, and they found out the answer in meter per second, but the question was in centimeter per second. So they lost all the marks because these exams will be mostly online, right? So computer will check. There won't be any humans to check the questions. So that is why if the computer is checking, it is not in the correct range, it is not in this range, that's why this range is given to the computer. If it is not in this range, the whole question is gone. You will spend almost 20 minutes in this question and you won't get the marks even if you are right. So please be very careful with the units. Okay. So this was the last question. You please solve this again, and in case of any doubts you can ask. So any doubts for now? Any doubts in any of the questions?
No, ma'am.
Okay. So we will close the session. You can ask your doubts. Yes.
Thank you, ma'am.
Okay. Thank you. I'll post my website in the chat box. So if you have any doubt in between the week, you can ask the question. Okay, you can use this website and ask the question if you have any doubt in between the weeks. We'll see you next week then. Okay, bye bye.